In this video, we're going to look at key features of piecewise functions. So for any function, there are lots of ways to describe the graph and pick out certain key features. So we have our piecewise function and we have it graphed. We're just going to pick out all sorts of information that's related to our graph. So for number 1, it says find the following values, f of -4. So I'm going to go on my graph where x equals -4. So go over to x equals -4 and then go to that point on my function, and I see that y is equal to -1 at that point. So f of -4 would equal -1. If I go to f of -2, so if I go to f of -2, that's where x equals -2. I go look at where that is located on my function, and it looks like y is equal to -3 where x equals -2. So that's it for that part. And then f of 0. So if I find f of 0, that's where x equals 0. So on my graph, that's where y is equal to 1. So that's all I need for that one. And then for f of 2, I go to x equals 2. And then I look on my graph, and that's located at y equals 1. So f of 2 would just equal 1. So I have found the following values. What are the x-intercepts or zeros of the function? So x-intercepts, I'm going to use my highlighter. I've got one at -5, +1, or excuse me, -5, -1, +1, and that looks like all of my x-intercepts. So let's write those down. So I have one at -5, 0, one is at -1, 0, and one is at +1, 0. Let's write those as ordered pairs. What are the y-intercepts of my function? So I'm just going to use a different highlighter. And I see the y-intercept is located at 1. So let's write that one down. So that's at 0, 1 is my y-intercept. And then it says extrema, what is the maximum value and what is the minimum value? So let's look on our graph and see what is the highest point, which looks like this one is the maximum point, which is located at the point 4, 3. So if it's located at 4, 3, they usually are indicating the y value is what they're looking for. So I would just say that's at 3. But sometimes they ask you for the whole ordered pair, and you might want to know 4, 3 is that point. And then it says what is the minimum. So if I look down at the minimum points, I have 2 to choose from. But one is open and one is closed. So I would just use the one that is closed. And let's say that's at -2, -3. And then a lot of times they just want the minimum value, which is the y value at that point, which would just be -3. Then it says use interval notation for the following questions. In what intervals of the graph is the function increasing, decreasing, and constant? So let's take a look at increasing, decreasing, and constant. So I'm going to zoom in for a minute. Let's use our highlighter. So from left to right, if we're looking at this graph, the black line is going down from left to right. So that one is decreasing. So I'm going to just write that down for a minute. So let's write it's decreasing right there. And then my graph takes a turn and starts to increase. So from that point up to the top of that little parabola, it is increasing in that interval. But then it turns around and starts to decrease again. So I'm going to put that in green. I'm going to write that down. So it's decreasing again. And then on the blue graph, looks like it's increasing even though it curves. It's continually increasing over there. So I'm going to write increasing over there. So we have a visual of what's happening. Now let's write it down in interval notation. So your intervals are talking about the x values. So in my first interval, I am decreasing from this interval of x values that goes from -5 to -2. And it's really that interval of the graph. In that area of the graph, my function is going down from -5 to -2. So I'm going to put -5 with a bracket because that endpoint was solid up to -2, but I'm going to put a parentheses at -2 because right at -2 it changes direction and it starts to increase in the next interval. So let's highlight that interval. So it looks like it is increasing between -2 to 0 for my x. Remember, you're thinking about the x values. So let's grab -2 would again be a parentheses, and then let's look at what happens at 0. So at 0 it changes direction again, so let's put a parentheses there. And then let's see, our next interval was decreasing, so let's highlight that it's decreasing from x equals 0 on over until x equals 2. So in that interval of the graph, my function went down. So from 0 to 2, let's write that down. And I need to add that to the decreasing interval. So I'm noticing I'm putting these in the wrong blank down here. So fix your notes. I'm talking and not paying much attention to where I wrote that. So decreasing, let's start, was -5 to -2. And it's also decreasing from 0, but put a parentheses because that's where it changes direction. And it goes to 2, but then it stops decreasing. It's not equal to 2. There's an open dot right there, so let's put a parentheses. Then increasing, sorry about that. It was increasing from -2, and we can put a parentheses because that's a turning point in the graph. And then it increased up to where x was equal to 0. But then it also was a turning point and started to decrease at 0, so put a parentheses. But it's also increasing in this interval with the blue squiggly line. So in this portion of my graph over here, it's increasing again. So even though it turns a little bit, it's continuing to increase from 2 to 4. And both of those dots are solid, so let's put a bracket from 2 to 4. And then it says, in what intervals of the graph is the function constant? In this case, we actually had no intervals that were constant because there were no areas of the graph that looked like they were just flat. So let's write none, and then list any points of discontinuity. So any points on the graph that are not defined from the beginning to the end of our graph. And so if you look at the graph, there's no, let me erase some of this extra stuff now, and then we'll talk. Okay, so from the beginning of our graph on the left, so the -5, if we look all the way around, so down, and then we can go back up, there's no holes in the graph that aren't taken care of. So like there's a hole at x equals 2, but then the blue graph, the blue piece of our function has a hole filled in at x equals 2. So there's no point of x that's not included from the left to the right once we began our function. So there are no points of discontinuity. So let's just write none again. And it says, what is the rate of change on the interval from -5 to -2? And so what we need to do is look at x equals -5 and find what the point would be right there. So -5, let me erase that extra stuff again. -5, 0 is that point. So let's write that down. -5, 0. And then -2, so that's our end of our interval. So from -5 to -2, they're asking what is the rate of change in that interval. And -2 goes with -3. That's where it's located. So we need to pick out those endpoints of that interval that they're asking you about. And then we just need to find the slope from that pair of points. So we use our old slope formula. So slope is y2 minus y1 over x2 minus x1. Remember, it's rise over run. I'm sure you've heard that phrase before. So let's label our points. The first point we could call x1, y1, and the second point we could call x2, y2. And then we could fill in our formula. So y2 minus y1 is negative 3 minus 0. And x2 minus x1 is negative 2 minus negative 5. And then let's just clean that up. So in the numerator, I get negative 3. And then in the denominator, negative 2 minus negative 5 turns into negative 2 plus 5, which is 3. And then I get negative 3 divided by 3. So my slope, my rate of change, that's what slope means, is just a negative 1. So in that interval from negative 5 to negative 2, my rate of change was negative 1. So there's just lots of things we could find from our graph. So hopefully this helps you to look at one nice big long example so that you can try some of these on your own.